This is a very quick video overview of graphs. Graphs is a very cool topic, and there are a lot of different types of graphs. So first of all, what is graph? Graph is a structure in which there are a set of vertices. Sometimes people call them nodes. You can define it like that. Big V, and the set of edges or links define it like that. Which connects pairs of vertices. Connects pairs of vertices. So graph typically looks very simple. Graph looks like a bunch of nodes connected with vertices. So this is a simple graph which is undirected and unweighted. So it could be defined as G is equal to V. It's kind of mathematical notation. So vertices X and Y of edge XY are called endpoints of this edge. Alright, so what are other different versions of the graph? What kind of different variants we might have? So there might be multigraph. So multigraph is the graph which has multiple edges connecting same vertices. In simple graph, there is only one edge that connects two vertices together. So there are like theoretical, mostly infinite graphs. It could be some types of the graphs on the stream. However, in most cases, most problems deal with finite graphs, and most algorithms deal with these types of graphs. Graphs could be directed. Another version where we have a set of vertices and the edges are actually pointing from one vertex to another vertex. Sometimes there might be, if it is multigraph, might be two vertices pointing, creating like a cycle from one edge from one vertex to another. So this the one of the kind of subversions of this directed graph is directed acyclic graph. This is very common in the kind of pipeline creation applications like Spark, Airflow, job scheduling, etc. So in that case we have a bunch of vertices, and even though they are kind of directed, there is no cycle in this graph. And of course there might be some mixed graph where we have a bunch of undirected, unweighted edges, and some of the edges might be directed. Right, so in addition to that, we have of course a whole class of graphs which are weighted. The weighted graphs have weight associated with edge, for example, like that. So it could be, for example of this graph could be a direction, a distance between cities, something like that. So weighted graphs can be put into two categories. One is a positive only edges, and another is positive plus negative. And depending on which graph you have, the algorithm might be completely different. Positive plus negative are very much more complicated than just positive graphs. Okay, so another type of graph is weighted directed type of graph, where we have a bunch of nodes, and not only we have weights associated with each edge, but also we have a direction here. So what kind of problems could be solved with this? Typically, when we talk about this kind of types of graphs, very popular is quantities like network and the algorithms for these types of problems. Typically something like max flow, min cut. Another very simplistic version of the simple graph actually, or weighted graph, could be a tree. The tree is a type of graph where there is only one path from any two edges, from any kind of x to and y. There is only one path. So the tree, there are many different types of trees, like binary trees, where the node has only at most two children, or any different types of trees. So like whole class of algorithms related to trees and different types of them. Okay, so there are different a bunch of other characteristics for the graph, like for instance connected, which means that for any x and y there is a path, exists a path from x to y. This is connected graph. Contrary, there is like disconnected graph, where there is a bunch of kind of isolated clusters, and for some of the x and y there is no path from one node to another node. There is bipartite graph, which means that we can create two disjoint sets, such that in each set all the vertices will not have a common edge. All the edges will be external, like that, for instance. There is a special case of bipartite graph, which is like connected bipartite graph, where in case of connected bipartite graph, all the edges are connected. Okay, I'll continue in the next video. I'll have to go.